So there's a special case that's going to be useful to consider. So suppose we have two events, A and B. We say events A and B are independent. Events. If either probability of A given B is equal to probability of A, or probability of B given A is equal to just probability of B. What does this mean in English? Well, this means that knowing event B happened did not change the likelihood that event A would happen. It didn't change our calculation of how the probability works out. And in this case, knowing event A happened, that given, that assumption, didn't change the probability that event B happens. Okay? So let's consider an example. Suppose I tell you that I want to know the probability that it rains in California on any given day, on a randomly chosen day, okay, in randomly chosen location of California. Say the probability, for sake of argument, is 10%. Okay? Now I'm going to give you additional information. What if I also tell you that this day is a Tuesday? Does that change your probability? No. Knowing that extra piece of information doesn't give you additional insight into whether it's going to rain or not. The day of the week has no impact on whether it's going to rain. Okay? So those two are independent events. Whether or not it rains and the day of the week are independent events. Knowing one does not change the probability of the other. They totally do not affect each other. Okay? Let's look at another example. So those two are independent events. What if I draw a card and then without putting that card back, draw another card? Are those two events independent? No. So drawing two cards without replacing the first one are not independent events. Why not? Okay. Well, if I draw a card, let's say it's the Ace of Spades. Okay. Now I have that Ace of Spades in my hand and I go to draw another card. That deck isn't the same deck I started with. Because I grabbed that Ace of Spades, the probability changed. For example, now I can't draw the Ace of Spades. I have already drawn it. It's not possible to draw another one. Okay? So generally, drawing two cards are not independent events. What is the first card I draw will affect what card I can draw for this drawing that second card. Okay? What I did the first event changes what's possible in the second event. Okay, and knowing what happened in that first event will help me adjust my probability for that second event. Okay, so generally drawing two cards are not independent events because with the first card removed from the deck, the cards that I can possibly draw in the deck have changed. So this gives you some intuition on what these independent events are. Okay. Now I should say that either of these formulas are true, or both of them are true, or neither of them are true. Okay. So both are true, or neither are true. And that's the way how independent events work. If knowing B doesn't influence A, then knowing A also wouldn't influence B. They're totally independent. Okay? So you only have to test for one. When you are checking if two events are independent, you only have to check one of these formulas. As long as one of them is true, then we know both are true. So why do we care? Well, it turns out our multiplication rule can be simplified if we know two events are independent. Okay? So remember our multiplication rule. And I'll just write one version of the rule here. Say probability of A and B equals probability of A times probability of B given A. Remember that? But in the special case where the two events are independent from each other, if A and B are independent, then what happens? If A and B are independent, then probability of B given A is just equal to the probability of B. That was one of the formulas we talked about before. Okay, so I can swap this this component of the formula out with just probability of B. So if A and B are independent, A and B are independent, the formula simplifies to probability of A and B equals probability of A times probability of B. And that's very nice. You just multiply the two probabilities individually. You don't have to worry about the conditional probabilities. Okay? Now, a couple words of warning here. This nicer formula doesn't always work. It really is important that you check that A and B are independent. If they are not independent, then this formula does not apply. Okay? If you are not sure if A and B are independent, then you cannot use this simplified formula. Okay? You need to use this more complicated formula. So if you're not sure, use this. If you can show A and B are independent, or if you're sure they are independent, then you can use this nicer, more simpler formula. Okay? But only then. If you're at all in doubt, use this one. Also, even when events A and B are independent, this formula works if they're independent. But this formula always works whether or not A and B are independent. So even if A and B are independent, this formula would still be true. This formula is always true. This formula is only true if we know A and B are independent.